Okay, quantum symmetry. This is super complex, and I'm going to be simplifying a lot. And I'd also like to note that I am not a quantum physicist, though I am friends with some, and they have helped me with this. So first, we need to explain what symmetry is to begin with. Symmetry is when you do something to something, but that something is not changed. For example, translational symmetry is when you move something. When you're done moving it from one place to another, it's still the same thing. My hand has translational symmetry because it's still my hand after I move it over here. There's rotational symmetry when you rotate things, reflective symmetry when you reflect things. There's even symmetry through time. My hand is my hand now, and still now. And as we get into the world of quantum and particle physics, there are symmetries that have to be obeyed there as well. Time symmetry is a big one. Basically, you can have the same rules of physics going forward and backward. There's charge symmetry, which states that if you flip all positive charges to negative and all negative charges to positive, the thing that's happening basically happens the exact same way. And there's parity symmetry, which is basically kind of like the mirror symmetry I mentioned before. Basically imagine a mirror world, a world where everything's reflected. The laws of physics work the same way in our world as they do in the mirror world, even though things are reflected. And if you only existed in one world, there's no way to tell if you're in our world or the mirror world. Functionally, there is no difference. Now, in short, we used to assume that all these symmetries basically held true. They were rules of the universe. But in 1957, we realized that this whole mirror world symmetry thing didn't really work. We supercooled atoms and had them radiate out electrons, and we found that there was a preference for which direction they went. And that could essentially determine whether or not you are in the mirror world. And so we explain this by saying, well, if that symmetry is broken, then there's another symmetry that it's entangled with, charge. So if it's going in one direction, it's positive, and if it's going in another direction, it's negative. And then in 1964, we realized that that's not true. So then we entangled all of them together, charge, parity, and time. I.e., if certain symmetries are broken, then we are looking at things going backward in time. We're basically looking at the universe reflected on itself in some way. Now, for the most part, that holds true. However, we are finding more and more symmetries at lower and lower quantum levels. And we are seeing more and more substances that break those symmetries. And there are certain symmetries that, if broken, would completely destroy our understanding of physics. Like if the combined charge parity time symmetry is broken, then we would have to rethink all of relativity. God, 3 minutes really isn't enough for this, but Veritasium did a very good YouTube video on it. Just search quantum symmetry and you'll find it.